at the AHR EXPO. Let's go check out the trade show floor. This show is mostly for commercial buildings and industrial buildings, like you see with the giant stuff behind me here. So it's sometimes a struggle. I'll just walk on an entire aisle and not see anything that's for homes, but we are gonna find the things out there. At the Renewaire booth with my buddy Nick Agopian, the real one is over there. But we've got this new ERV, which is very cool. And by the way, let me see this, because Renewaire has a really good line of ERVs. They are owned by a company, is that right? Owned, yes, right?
Yes.
That is European, and they make like a crazy amount of very interesting, very unusual things for what we'd see in the States. And one of the things they're bringing over is a lot more controls. And so you'll be able to see like new ways of controlling all this stuff, which my favorite thing on this is the occupancy sensor. And we're gonna get more into demand control ventilation in future videos, so make sure you subscribe. But this one is their EV line, which has tapped out at, it goes from like 30 CFM to about 200 until now. This is the Model X, which is gonna go up to 350, is that right? 400 CFM on boost mode. And that's really useful because like a lot of my clients will have 2 HVAC systems and it's like, if you get 2 HVAC systems, now you're talking about 2 ERVs. Or you could have one that can handle both of them, and all you do is you'd come out and you'd split into a T and make sure that it's the same length to the 2 air handlers if they're close to each other, which like they're probably not in reality, but more efficient air movement with EC motors. And by the way, these things can perform up to 1 inch of water column, Nick promises me. That's pretty amazing because a lot of ERVs are not, they're weak. So MERV 13 filter, that's very useful. We may see from them soon carbon, activated carbon, and also better filtration, potentially like a MERV 16 or a filter box that you could add on, right? Things like that. Okay, so this is another solution, the EC, by the way, really important, being able to dial in your flow, not just choke it down with the dampers, which is what like a lot of lamer versions would have. So lots of the features, think about features when you're shopping for these, not just CFM. Quick reminder, we've got big bath fans and small bath fans. You can do almost anything with a 50 CFM bath fan. You don't need a giant one if you put it in the right place. Also, just a quick reminder that they all come with this piece of tape right here on the backdraft damper. You are supposed to take this off. In fact, it says remove this tape. And I swear to God, I have had builders where I couldn't get any airflow. I'm testing the bath fan and I'm like, did you take the tape off the damper? And they go, of course we did. What do you think we are, idiots? And then they get up on a ladder just to double check, just to make sure that I'm not right. And like, well, son of a gun, we didn't take the tape off of that thing. So don't forget to check your work. Here we are at the Broan booth with Travis, who I like to come and ask hard questions of. So first thing that I'd like everybody to know is that. What is that thing, Travis?
That is our new AI 2 series. So kind of taking the platform, going to a larger CFM, 200 plus CFM with both ERV and HRV.
Awesome. And this has been a problem. Let me describe what the problem has been first. I'm going to put my coffee down so I don't spill it all over traffic. Can I show real quick? Yeah. This is what the AI is. I have a video that I've been working on this specifically, but that is how you commission this system. You just tell it, I want this many, and you go boop, 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 and it says, okay, great. And then it tests itself twice per second.
Yep, 2 times per second.
Which is way more often than somebody like me would test it one time when we're actually setting the thing up. So 160 used to be the high end of where this was, and then they had other lines that do bigger. But the AI is like, that's the whole thing, because if you get an ERV and then it doesn't get set up right and it doesn't run right, it's almost like there's no ERV there. So we need one that's like really easy to just set up. You just say, boop, I want this, and then it does it for you automatically. So 210 is now the
210 CFM ERV, okay. 230 CFM HRV.
Okay, great. And for the record, no offense, but I'm recommending ERVs for almost everyone in the universe. You're nodding. Tell me who wants HRVs and why?
Yep. So a couple things. So I generally joke, if you're living with the polar bears, you're still using HRV. We've come a very long way with our defrost cycle, as well as the ERV core materials, that we can confidently run at those much colder climates That was not the case 5 years ago. So we still have a lot of guys using HRVs, been doing it for many years. They want to stay that way for now, but we're starting to see that line creep up further and further north with where an ERV is acceptable to use.
Cool. Okay. All right. This is the kind of commercial equipment that you see a lot, but this one is really interesting to me. That is an enthalpy wheel. That is an ERV core, basically, but it's a wheel and it's made to spin. And if you can imagine, that thing is designed to spin at 40 to 50 RPM, the same as this one right here. Isn't that crazy? So what happens is that when you've got, this one is a sensible wheel. So this would be an HRV core, but it's got this little motor right there that is, attached to a belt that's spinning that thing around. And it's spinning so fast, and it's got this kind of return on it.
So it basically is 80%, somewhere in 60%.
66 degree incoming, 88 degree outgoing to the outside. Coming in at 99 degrees right there, and this wheel cools that down by capturing the incoming or the outgoing exhaust air and then brushing it up against this what did you call it?
It's polymer.
Polymer. Yep. So special chemistry, right? Special materials, special chemical properties. And it ends up being 72 degrees coming in. That one right there is designed for 35,000 CFM to go through it. They spin this one a little bit slower because the humidity exchange takes a little bit longer to do. But this is kind of what we're looking at. See how pretty that is? So it's got the temperature and humidity exchange on this going through it, spinning that fast. And they said, there's a reason we're not really making those for residential, because most people just prefer a nice, clean energy recovery ventilator core, which looks like this. And you've seen this a million times on my channel, but that's a lot more comfortable for homeowners right now. Also, I was like, well, doesn't the power draw of this little motor pull against the efficiency? Because this one, total efficiency with heat and humidity, we're looking at like 60 to 70%. A normal ERV core in the residential space, really more like 40 to 50% total efficiency. That's temperature and humidity. And he said, actually, the whole power draw on that thing right there is in the startup mode. Once you get it spinning, the inertia of it just keeps it running. And I thought, well, that's basically like my ceiling fans, which I keep running in my house all the time. So they're just running at 20 to 30 watts nonstop. So anyway, I think that this kind of an approach, looking at how commercial buildings are doing it, and then trying to apply those things to homes, is just really fascinating. And here's my annual reminder that blue lights and anything that's more than a fan and a filter is not a good idea in homes. For commercial buildings, for hospitals, for airports, like that's the argument. Well, we use this in hospitals all the time and they make it work. You don't have a maintenance person who is going around checking this stuff on a regular basis on a schedule as part of their job. These introduce all kinds of chemistry that is going to interact with all the personal care products that we are wearing and that we use for cleaning and we cook with and all that stuff. A home is not a commercial building. Please don't use blue lights and stuff like this. Now, it's really confusing because they say things like, particles are only 1/3 of the equation. And of course, when we talk about it, we're talking about particles, chemicals, and microbes, and they're right. So thinking about it that way, filtration still is the way to go. You don't want to impact the other 2/3 of it, because doing that has all kinds of side effects that we just can't predict in residential structures. The marketing might say things like, your HVAC system is a breeding ground for bacteria and mold and things like that. And that's like not true. Your face is a breeding ground for microbes. So let's be realistic. Everything is a breeding ground for life. Life finds a way. It's not hard to get confused about controlling the indoor air quality. Even manufacturers get confused about this a lot. So here's a company that makes filters that are like very nice filters, MERV 13 with carbon, and they even have come out with a line of ionization and blue light and UV. Normally, filter manufacturers and blue light manufacturers and ionization people, or AKA passive air cleaning and active air cleaning, are on the opposite sides of the fence. And here's an example of a company that, even within the company, is a little confused about what exactly the mission is and what the side effects are that they're trying to induce. And you guys, if you have to have a fireplace, will you please, at very least, just come to the showroom and bring your bear rug and just make love in front of the electric fireplace and see if it's just as satisfying as a roaring open hearth fireplace. Just try it before you make the decision. This is Jason LaFleur, who we came up together in Chicago, and it's like everybody knew us when we were just starting out. So anyway, Jason now does research, and he was about to tell me a story, and I told him to stop talking so that I could get it on video. So we're talking about Passive House had this thing where, and I don't know if they're still talking about it, but like you have a recirculating exhaust hood over the kitchen, and then you have an ERV exhaust somewhere in the kitchen.
Somewhere in the ceiling, elsewhere in the kitchen area.
And so I was like, that's stupid, right? And he goes, right. And so now he's got a story. So
the bigger issue on a multifamily building is that you have buildings, 20, 30 feet up in the air with intake ports for an ERV. Because the cheap way to do an ERV is to just go right up the sidewall, right?
Yep.
So the challenge, we're doing some research on one of these buildings that was built 5-6 years ago, 3 years after occupancy, looking at the intake port at ground level, and it was completely covered with all kinds of debris, cottonwood trees, whatever else is floating around in the urban environment, right? So like the actual flow going into the home from the fresh air intake was almost minimal.
And this is potentially 3 stories in the air where a ladder, you're not going to take a ladder
No one's
up there.
ever going to repair that thing. So like it's a really critical aspect of ventilation design is thinking about where that intake is going to get to and how that could be maintained. If it's constantly pulling air in, most of them are 24/7, right? How is that going to be maintained in the future?
So that's good, because I said recently about my house that I wouldn't put it as close to the ground as I had it because bugs. But there is such a thing as too high. And also ERVs don't work for exhausting out of kitchens. Thank you.
More to come.
A bunch of people have asked about the makeup air for kitchen exhausts and whether we can hook up a dehumidifier to that. This is what a dehumidifier that can dry 800 CFM looks like. So you can see that this is almost as tall as I am, and it would take up almost an entire room on its own. This right here is the exhaust. This is a desiccant dehumidifier, and the exhaust, just like the little eCore Pro units that I put into our tiny lab and into our dry vault where I keep my tools, has the moisture come out as wet air. So it doesn't have a condensate line, and that right there is 200 CFM of exhaust flow. Remember, my blower door test is 300 on my house. So this really is like, aside from the fact that it's so huge, just an impractical application for residential. Oh shit. Humidification. That one is an atomizing, or what you'd call like an ultrasonic or misting humidifier. That don't use in homes generally, because whatever is in the water will end up in the air. So chemicals like chlorine, things like microbes, things like that are going to end up inside the air. This right here, what my friend is pulling apart, is a steam humidifier. And I've been recommending, I have a video with the Aprilaire 801, which was a modulating steam humidifier. They've cut that, and they only have the 800 number now, which is not modulating. I believe it's just a 1-speed, it turns on, turns off. This one, that one starts at 11 gallons per day, by the way, of output. This one is 5 gallons per day, which with my humidification video that I just made, if you've got multiple systems in the house and you're trying to humidify, this one is the size that you're looking for if you have an efficient, high performance home. You don't need something that's as big as something like this, or like in my case, that Aprilaire 801 can do up, from 11 to like 35 gallons per day. I don't need that. So why would I install something that's that big? This little guy right here, I'm impressed with how efficient it would be. And it's fully modulating, by the way, which is important. Because if I only need a little bit of humidification, I only want a little bit of steam. I don't need full speed ahead on that. So just, there's more options for this. And that's the kind of thing that honestly coming to a trade show like this is really for. Here is an interesting solution for crawl space ventilation specifically. Let me show you something. This is called the Atmox system, and it's basically a control system that is paired up with fans into and out of crawl spaces. So they're not, I was like, oh, is it exhaust only? And she said, no, we like balanced ventilation. And I thought, ooh, yeah, I like that. So you put one of those on the facing inward, one facing outward, and you can see that they come with these louvers to make sure that when the system is not needing to be run, then it's closed off. But what the control system will use is a series of monitors. We've got an air temperature relative humidity monitor that is comparing with the monitor outside. So we've got temperature and relative humidity in and out, and it's got a dehumidifier option so that you can know that if the outside temperature and humidity is not going to be appropriate for bringing that in to flush out indoor humidity, then we just use this to kick on the dehumidifier instead. But this is kind of a cool thing too. So this is a pin material moisture sensor. And I was like, where do you put that? What joist in this crawl space are we using? And they said, actually, no, it's just this block. This block is a surrogate for the wood inside the crawl space. And I thought that was kind of like, you know, taking the rocket science out of this stuff is important, and making sure that it's foolproof. So anyway, this thing has DC power, and it can run these little circulation fans, which you just hang from the joists. These pump 72 each, so it's like 140 CFM for each of these things. And essentially all the idea is you just set one up in, if you have a simple spaced crawl space, one in each corner. You try and set up like a little roller rink of circulation, which is the first factor of ventilation that we're always worried about. And then you've got the fans going in and out so that everything makes sense. And I think that that's a pretty good system. So thank you guys very much.
Thank you.
Best swag I've ever seen in my life at one of these shows. Don't forget that when you take a sealed combustion piece of equipment like this, it's supposed to take air from outside, combust it, and then send the combustion air to outside, and you do this to it. It turns it from a sealed combustion piece of equipment into a power vented piece of equipment, which is still connected to your house, which is less safe. So this conversation about party load air conditioners, when like, what if I want to have a party at 5 o'clock in the afternoon on the hottest day of the year, and I have a bunch of people over, and I've got this little 1.5 ton air conditioner in my house, and now I've got 50 people in there. If you're really that popular, I'm very happy for you. But this is one of the things that you might consider. The other thing is like what Matt Reisinger puts on his channel, which is a party load system, which is a mini split on the wall, maybe a 1 ton, just to handle that what if. These things, you might be tempted to just go to Home Depot and rent one, but this is a commercial application. And here's why it's so important to distinguish between the two. This is a packaged unit. And the way that an air conditioner works is it takes heat from one place and puts it someplace else. It also takes moisture from one place, which is the air inside your house, and puts it somewhere else. This one takes the moisture from the air and then puts it down a condensate drain that would come out the bottom here, just like a normal air conditioner would. But the condensate, or the compressor fan, is inside this box too, and we have to put out the hot air that would be blowing up along the side of the house on the outside of the house in a normal split system. This one is coming out here, and it's 700 CFM coming out of this that you'd have to duct to outside. So you can't take this 1 ton. This is just 1 ton. Look at how big it is. 1 ton system and put it into a house for a temporary thing, because like the amount of infiltration, the air leakage that this would cause, and the depressurization that would cause all kind of other issues would possibly be massive. So be careful about that. At the Mitsubishi booth, you can see that things just kind of keep getting incrementally better. So this is called the FW Ductless Mini Split, and it's like basically the same, but they keep getting it better. So this one's going to have hyperheat. They have a new hyperheat version. Hyperheat was 100% heating capacity down to -5 degrees Fahrenheit. This one is hyperheat Sumo, which is 100% capacity down to -10. So little things like that. They redesigned this IC sensor, which is this infrared camera that basically reads the room, and it's quieter now, and it's like a dome instead of a little post that sticks out. But I think that like some of the same challenges that we still have with ductless mini splits, like filtration, like the ability to pull water out of the air, are still an issue, which is why they're duct-dead systems, both ducted multi-position air handlers and ductless or ducted mini splits, like this one right here, which we'll have more about on the channel soon, are both really important to consider. So the ducted air handlers that are central air handlers. Those are really interesting, and I'm going to talk about that in an upcoming conversation about switching over from furnaces to heat pumps. And this is the only booth that I've ever gotten yelled at in for asking too many questions, for what it's worth. With all the talk about mini splits, I get people asking, well, what about the DIY kits, which this is one of. This is the Mr. Cool booth. And so they've got, just like everybody's doing, one outdoor condenser with up to 4 indoors. And so my question was, okay, but what about all the things that you know that a professional has to do, like pulling a vacuum on the line set, like doing flares, like cutting the line set and fitting it and all that stuff. And actually there's some pretty interesting things here. Number one, you are not allowed to cut this line set. You will void the warranty at that point, because this line set is pre-charged with refrigerant. So the refrigerant is inside this line set right now. It comes pre-insulated, and it's got these little fittings on the end. So that is a spring-loaded little tip on that. And when you start screwing the thing together, the refrigerant starts flowing. Now, if you have 4 heads, the line sets that they have, it comes with like a 25-foot length. So you can imagine a house where you're going to put one of those condensers outside, and then you have to have 25 feet or 16 feet if you wanted the option. 16 feet or 25 feet of length to each one of those. That's not going to work. Like in my house, my furnace sits in a place, my heat pump sits in a place where I have 140 feet to the compressor outside. That's just not going to work. So what they say is, oh, well, you can just daisy chain these together. And then I said, well, wouldn't you have to add more refrigerant at that point? But of course, remember that these things have their own refrigerant in it. So you could just make this as long as you want, and you'll have the right amount of refrigerant inside the system. This thing comes pre-charged with refrigerant. This is pre-charged. That comes pre-charged. The outdoor unit comes pre-charged. It's like a pretty interesting approach. I think that solves some interesting problems. These are ducts. This one's not, but these are for underground. And I had a client recently ask, like, what if I pre-cooled my incoming air from my ERV by running it through the ground? Since he has this walkout basement situation where one side of his basement is completely exposed and the other side is completely underground. What if we use that? Now, the reason that these are going to be insulated is so that you don't have condensation forming on the inside. So it's insulated. So it actually wouldn't do that heat exchange that we'd be looking for in the case of an ERV, where you basically are calling the ground a secondary heat exchanger. It'd be very interesting. But if you took away the insulation so that actually worked, what you would end up with is condensation on the inside of these things. And that would grow all kinds of biological civilizations that would then be potentially problematic for your family. So be careful about that too. But it's an interesting application, and it was a really cool idea. I really liked that. I was accused this weekend of being a little bit obtuse and trying to make this stuff more complicated than it needs to be, but I think it is complicated, and it does need to be complicated, because something as simple as R value, which this is Reflectix installation, and the problem with how these guys are forced to market this stuff is that they're competing on R value. The R value test is a test, which this channel is kind of obsessed with. And what they do when they set up an R value test is they put this something that you're trying to measure flat, and then they heat one side of it, and they see how long it takes for the heat to migrate to the other side. And that does not account for the radiant barrier in this product, which is, so basically what we've got here is the R value that they are claiming here, which I'm sure is real, is an applied R value. It's an R value actually of the assembly of this, not of the product itself. Because if you use this spacer, what you're getting is an air film on the inside of this. And then the radiant barrier facing the inside works better. Also, you have a radiant barrier inside this little sandwich right here. And so what we're measuring there is the radiant barrier on the inside, both facings, plus the air bubble. And if you just measured the R value of the product itself, we're looking at like a little more than like R1, but not a whole lot. I think they might have said R1.5. So what you're getting here is radiant barrier, radiant barrier, radiant barrier, radiant barrier, plus the actual air bubble inside. So the spacers application is really important, and I think that that is an important message for everything that we do on this channel, which is all about, it's not the product, it's how you install it that's so important. So this actually, I mean, I think I'd prefer doing this than the Cat P fiberglass insulation that we started installing on ours. My installation is not fully installed in my crawl space still, but I don't have to because I'm still monitoring that. Stay tuned for a video on that topic, actually. There's a way to insulate ducts with spray foam, which I think is like an interesting idea, but in execution, you never get ducts that are just hanging out, open, easily accessible from all sides. And I've seen this happen in actual homes. There's framing in the way. So you're gonna get most of the duct, but then there's gonna be some spots that you miss, and it might be a lot of spots, like the entire underside, for example. So I think that in execution, it's actually got, you should be very cautious about this approach. This is a great look at the flex duct options that we've got. Now I wanna just point out a couple things. This is just regular uninsulated flex duct. You can see how rough it is on the inside. That's what your air flow is having to fight against. That's why flex duct is normally going to introduce a higher static pressure than smooth duct. So you want to make sure it's nice and stretched taut. Now you've got insulation that goes in around the outside of the flex duct. Here is an example of like the minimum that you'd want, 1 inch of fiberglass. Now this would be what you'd want minimum for your bath exhaust fan, because it's going to be exhausting hot, humid air inside, cold attic air outside often, or in crawl space, etc. So dryers and bath fans, you'd want to have this layer of insulation. Now, even when you get down to something like this or like this, that is a lot of insulation. That's going to probably be like R12 maybe. It looks like they tried to wrap an R13 bat around this thing. Anyway, you've got potentially Mylar coating on the outside, which is going to add another layer of thermal resistance against radiant heat bleed. But you want to be careful about planning for longevity for these, because cleaning the inside of this, you would use, they use these kind of like drill-based brushes, and they might actually, if the plastic gets old enough, it would shred this plastic, and then what you would be breathing would be fiberglass fibers that would be exposed to the inside airstream. So just, think about all that stuff when you're sizing this. That being said, flex duct is, it's here to stay. It solves some problems, and so we got to deal with it. But just know that you're adding the right amount of insulation, not necessarily maybe too much, not too little, making sure that you're putting it in places where it's easily replaced later on when you are going to have to replace it, which it is going to die someday. I know somebody's going to comment on this thing with like, oh, it lasts forever and ever. I'm not sure about that. Now they do have duct cleaning equipment that is for flex ducts. You get all these different heads. So this would be a little head, and you can see how like it's pretty spiky. So that might damage your flex duct. But they do have, if you remember to replace the head on this thing, this, which is more for flex duct, and it's not going to hurt your pretty little flex duct. So that's nice. But the one that's for honest to God metal, long-lasting ducts is going to have these little spiky guys on the outside to make sure that it really scrubs that stuff off, because that's, there's stuff that, especially in flex, it's going to get into the creases, and that's where it's all going to live.
Level 2, 3, and 4.
And do your hand on it, if you would. Here's a new one. I'm not seeing a whole lot of like new things that are making me think really hard, but this one is definitely racking my brain. World's first tankless heat pump water heater. So the difference is we've got heat pump water heaters that are tank based, and then we've got tankless water heaters. But to get the amount of heating as the water is just coming through a machine of any kind at 60 degrees or whatever the ground temperature is outside, and then you want that, you expect it within a machine to go from 60 degrees to 105 degrees minimum. If it's something like a small point of use like that, which I have in our house, then you're looking at quite a bit of electrical draw. Like you need to wallop that water with energy. So this right here is, what is this?
This is the IE1, the Electron.
IE1, the Electron. See the little funny little face? Isn't that nice? So, Intellihat is the name of that company, and basically what they've got in here, they're cheating a little bit because it does have a tank in it. But what the tank is for is actually just a thermal battery. So what they're doing is using this heat pump on top. And the reason that we use heat pumps, my parents asked me the other day, they were like, should we replace our furnace with a heat pump in Atlanta? And I was like, yeah, well, it'll be more efficient. And the short answer on that is heat pumps can be like 300 or 400% efficient, which doesn't make any sense, but it's based on the refrigeration cycle. It's compressing a liquid into a gas into a liquid, making the liquid turn back into a gas, and that kind of like gives you a boost. So this thing is a COP, coefficient of performance of 4, so it's 400% efficient. The electrical grid is only about 30% efficient, a little more than that. So it's kind of a little bit of a wash, but it's a good thing to be able to do. When they make the electrical grid better, it's gonna benefit us. So they're using this heat pump to slowly warm up this battery, this thermal battery of just glycol liquid in here. And then they have this battery sitting in there at like 140, 160, 190 degrees. And it's just waiting. And what's cool about this is it's got a brain. So it monitors the usage. So if you put this into a single family home, which they said people might use this in a large single family residence, what you get is a 40,000 BTU heat pump, which is basically the same as a 40-gallon water tank. If you're looking at it like a gas-fired water tank, that's 40,000. So that's pretty small. I was like, wow, that's really small. And then what we have down here is like a big battery that's going to be able to contain that. And so you have something that could just, and by the way, this sits outside for a reason I'll get to in a minute, but this thing has the brain to be able to look at the pattern of usage and say, okay, everybody tends to take showers in the morning all together at 9 o'clock in the morning. So I'm going to have the battery ready with the heat pump to be able to not use the other thing that's embedded in there, which is a 12 kilowatt electric toaster to warm up the water as well, which, by the way, 12 kilowatts is not a lot. I have, most of the ones that are in my house are bigger than that. That is the condenser coils output. The reason that you can't put this inside the house or inside of a hotel is that thing is 3,500 CFM of output. So be careful about that. But anyway, I just thought like, that was really interesting. We were doing math together and like most of it has now dissipated out of my brain. I just thought it was like an interesting application. So these are the kinds of things that I think are going to lead to different ways of thinking, which is what this channel is all about. So just, think about the modularity of this stuff, because like heat pump water heaters are cool, but taking it to another level is like another thing to think about, because there's no one answer to anything. So there's a calculation called manual T, which we hardly ever get into because I solved it by just having ceiling fans running on low speed all the time. But if you really wanted to get into it, you could start sizing your delivery terminals, which is what T stands for, which is the supply registers. And a register is normally thought of as something that's got a dialable, like, in a normal register in the States, you're looking at a little arm that you can open and close. These are sexier. That's kind of cool. But you got bigger, and you get, like different shapes and sizes and all this stuff. And that's all very cool. You could certainly do that. And like, this is for people who are, thinking about something like the RE events that I showed off on my channel recently, because those are like very popular on Instagram. If you look at the performance specs, not that great. These have a nice big hole. The hole is what actually is going to move the air. So you want that. But unless you're going to be supplying at a certain like 500 to 700 feet per minute, then it really won't matter what direction you point these. You could point this up, you could point it down, you could do whatever you want, and it's just going to come out kind of nice and slow. So if you're going to be going that far with the math and really calculating these velocities that are going to be delivered, then that's one thing. But otherwise, we just use the ceiling fan thing. Ceiling fans are part of your HVAC system too, although they're not at this show, weirdly, so you won't find any. I wasn't wrong, but there are some ceiling fans. And Grace finally got to join me at the end. We're going to go to the party at the aquarium that's put on by Renewaire, and she's wearing her fancy dress.
Yeah, I've got my fun floof on. which is really fun to walk into a big dude trade show. And everyone's like, Ballerina just came to the mix.
So anyway, we hope that you have enjoyed the tour. Comment below, ask questions about things like that. Maybe I'll have an answer for you, I'm not sure. Like and subscribe, tune in next time.
Bye.